engineer from IISC Sipur. ME, again topper in mechanical design from IISC Bangalore, and then done PhD from engineering design, University of Cambridge, UK. He led for almost 10 years the design synthesis group at EPSRC COE Center of Excellence Engineering Design Center at University of Cambridge. His interests are in synthesis, creativity, sustainability, and informatics. He published almost 17 books, over 300 peer-reviewed articles, and has 11 patents granted, and few are the pending. So he also co-authored DRM, a methodology used widely as framework for design research. So very interesting topic, that is DRM also, that methodology. And he has been associate editor in AI IDEM and Design Science Journal, that is Cambridge University Press, area editor, research in engineering design, regional editor, remanufacturing Springer, and advisory editor for 8 journals, including Clean Technology, Environmental Policy, Materials Circular Economy, and J of Engineering, D, and Internet J Design Creativity and Innovation, that is TNF. So he was an advisory board and board of management design society member, CII National Committee on Design India, Jury India Design Mark, invitee CII Smart Manufacturing Council India. He founded one of the very popular thing, that Ideas Lab. If anyone is having any idea, then one should go through that thing. So for that purpose, Ideas Lab has been India's first design observatory created by Amaresh Chakrabarti sir, and he's program chair for International Conference Series on Research into Design, that is ICORD, and 22nd CIRP Design Conference 2012, third International Conference on Design Creativity 2015, that is third ICDC, and vice chair of AI in Design and Design Computing and Cognition Conferences. So this is just a brief, and if I can go with his the profile, then they will be very short to introduce him, and definitely we are here to learn from him. So I request Professor Amaresh Chakrabarti ji to bless us with your the valuable inputs on this design thinking. Thank you so much, sir, and over to you, sir.
Okay, thank you very much, Mr. Tushar Panchal. Thank you for inviting me here. I'm really honored to be able to present my ideas in front of such a large group of teachers. I think that's probably where hopefully these talks makes more difference. So let's start the talk. So I'm just sharing my slide.
Yes, sir.
Okay, please let me know if you are able to see my slide.
Yes, you can see your slide, sir.
Okay, and can you hear me clearly?
Yes, perfectly clear, sir.
Okay, fine. So let me start. Okay, so I would just like to start with, maybe if others can just mute their mics, it would be good. I would like to just use one slide.
Yes, I request participants to mute their mic, please. Or Kausalji, if you can control those. Yes.
Sure. I'll mute all the participants.
Yeah, please, sir.
Okay. Shall I start?
Yes, yes, sir.
Okay. So the first thing that I want to share with you is that if you look at the Global Innovation Index graph 2020, the one on the right side, the x-axis here is how much input you resource you put into innovation, and the y-axis is how much innovation output you get out of it, and that correlates very strongly, irrespective of which country we are talking about. Each dot is the performance of one country in the global innovation scenario. So clearly, if you invest more in innovation, it correlates with more innovation. The second is that the innovation leads to improvement in manufacturing, and this is again because manufacturing is the enabler with which innovation is implemented and taken to society. The third is that innovation also correlates with growth. So if you look at the graph on the right side, uh, some of these graphs are. So can we please mute the participants? I hear background noise.
Yes, yes, sir.
So I have muted all. Now just you unmute yourself, sir, please. Okay. Yes, sir. Sir, you have to unmute yourself because I have muted all the participants.
Okay, okay. Can you hear me now?
Yes, yes, perfectly fine, sir.
Okay, fine. So let me start it again. What I was saying was that if you invest more into innovation, then that correlates with more innovation. So the graph on the right side shows that if the x-axis is how much resource is put into innovation, and y-axis is how much innovation is produced, and every dot is for one country from the Global Innovation Index report of 2020. And you see that these two correlate with each other irrespective of which country. Second is that innovation also leads to improvement in manufacturing, because it is through manufacturing that the innovations go out to society. Third is that innovation correlates with growth. It leads to greater growth. So these graphs that you see on the right side bottom, they show that GDP growth correlates with growth in R&D input, which is an indicator or marker for innovation. And the fourth is that design is essential for innovation. Design ensures that right problem is solved right. And in order to do that, you require low investment while you get better decisions as a result, which essentially leads to a very efficient way of doing innovation. Now let's talk about efficiency of innovation. So this is what I call innovation cycle. Innovation starts with the society. That's where opportunities and problems and aspirations happen. And then they get solved or fulfilled through offerings that people make, and they go out to society. And if it's a successful innovation, it satisfies or fulfills the opportunities or solves the problems. And if it's not, then other cycle starts. Now, if you go inside this cycle further, then you see that there are 6 broad elements in this cycle. Okay, first is that we have to identify opportunities. Second is that we have to develop ideas of how to fulfill them. Third is that will lead to development of a system, that concrete system with which the idea can be embodied. And then production of how that will be implemented, supply chain, how this will be offered or delivered, and business, how this will produce money that will sustain the organization that is doing all this. So is each of these are or can be a valley of death, okay, where the innovation doesn't quite reach the expected output. One is that is the problem or opportunity valid? Are we solving the right problem? Does it have the juice? Idea is the most appropriate idea. Is this the most appropriate way of embodying this idea? Is this the most appropriate way of making this product? And is this the most appropriate supply chain for taking that product out to the society? And is this the most appropriate business model for taking it out? So all of these have to be good enough that the solution goes out to the society and makes a difference. Now let's do a very small bit of maths. Let's say that there is about a 50% chance of success in each stage of these 6 stages. Then the joint probability of success for all of these to happen, which is what is necessary for the innovation to go out and make a difference, is about 1.6%. So it is not surprising that most of the startups, for instance, fail, right? The national average failure rate of startups is about 96%. Now, they have all tried to do. They have all tried to do innovation, and yet many of them, most of them fail. Okay, now let's look at a slightly bigger. So if the chances of success are pretty high in each of these stages, then overall chances of success will be a decent one. So how do we make this happen? That's the question where design comes in. So let's look at how difficult it is sometimes, and it's not, failure is not only for the startups. Okay, this is Genesis space probe. This was a space probe that was launched by the NASA in 2001 in order to collect particles from the solar wind. I'm sorry, just one second. Just give me 1 second, okay? I'm trying to just turn off my computer, telephone. Hello, can you hear me?
Yes, sir. Yes, sir. Please.
Okay. No, I just temporarily lost connection. Okay, so I was saying that Genesis space probe was launched by NASA in 2001 in order to collect particles from the solar wind, and it had to travel 1.6 million kilometers from the Earth, and this would take about 3 years to complete. So in 2004, when the space probe comes back to the Earth's atmosphere, they had designed 2 parachutes rather than 1, in order to ensure that even if one parachute fails, the other one will float, and this will be in mid-air for a helicopter to collect the probe. So 2001, September, the space probe comes back, re-enters the Earth's atmosphere, and it hits the ground. So what went wrong? So there was a committee that was formed, and the committee found that the switches that were supposed to turn on the parachutes did not work, and it was very clearly based on the drawings and so on that were identified and shown that this was a design fault. Okay, so design can be costly, right, if it's not done right. And I will give you some now stories of success. So let's look at some success stories. This is an award-winning chappal that was designed by 2 of our ex-students, Govind Sharma and Anup Chander, who won the Red Dot Award, which is like the Oscar of design awards, where 4,724 entries from 58 countries participated, and they got the award for this concept. What is the concept? The concept is that the regular chappals, that are flip-flops that we wear, they splash water back to our body. So they came up with a chappal that has a diversion at the bottom that allows the water to splash sideways rather than back. This is another example, a life-saving hypothermia alert. So this is where another student, Mona Sharma, who is the design head of a company based on Bangalore, they came up with a $28 temperature monitoring bracelet that can fit into a baby's wrist. Babies have a problem called hypothermia. Hypo means low, thermia means temperature. So when they go down, their temperature goes down below a certain threshold. They need to be warmed up immediately or they will die. Okay, and there is a large number of babies around the world that die because of that. And so what Mona's group had done was that they came up with a temperature monitoring device and with an alert to the caregiver, and a very simple innovation, but a very important one that led to, in 2017, saving lives of 10,000 newborns in 25 countries, which is why the Time magazine, which publishes 25 best inventions every year, picked them up as one of the 25 best inventions of the world, not just India, in that year. This is the first racing bike that TVS designed. It's called Apache RR 310. TVS, by the way, also makes the motorbikes for BMW. And this entire industrial design, the look and the feel and the usability and so on, designed by another student, Arun Francis, who you see in the middle, and on the top, a sketch of himself by himself. This is the fourth example. This is Sickle Innovations. It's an innovation startup in the area of agri-tech, and I think you can Google Sickle Innovations and you will see that they are identified as the best agri-tech, farm tech startup in by FICCI and the government Department of Agriculture and so on, Ministry of Agriculture and so on. What is it that they had done? Originally, they did their master's project at our department, Center for Product Design and Manufacturing. They wanted to improve the cotton harvesting productivity of people. Okay, typically this cotton harvesting happens in a very small time window. They have to go and they have to pick up the cotton, and basically this is something that is not very efficient. It takes time and not all the cotton is picked up. So they wanted to improve both. Can we pick up more cotton in less time? Okay, or help a person pick up. So they did that, and they came up with a device and a appendage along with that. And this was incubated then in our incubator and further one at various other incubators, and they came up. And now they have expanded well beyond that. And all of these happened, and they're of course employing people and so on. The last example is the advanced affordable prosthetic arm. You see on the top right, my colleague, Mr. Eknathan, who is a forearm amputee. So he has a little bit of stump in the forearm, but his rest of the arm is not there. Okay. And so these two people that you see at the bottom, this is Vinay and Nilesh, they were also master students, and they took up a project where they wanted to develop a prosthetic arm for people. But there are so many prosthetic arms. So what's the big deal? The big deal is that most of these prosthetic arms are either too complicated and therefore too expensive and too unintuitive for people to use, or they are too simple and they do not work. So they wanted to have a prosthetic arm that will use only a single actuator in order to operate all 5 fingers in a manner that allows them to wrap up around arbitrarily shaped objects. Okay, that's a very difficult task. So they used a principle called under actuation with which they were able to do that. And the number of actuators roughly is proportional to the cost of the device. So as a result, this cost came dramatically down, and it attracted the interest of a global support group called Wellcome Trust, who then gave us about 10 crores to develop this even further. And Oxford University got interested, so a team was formed and they developed the next level of this. And now this has been launched as a company called Grass Bionics, and this company won the Elevate 29 award of the government of Karnataka last year. So what is it that is common across them? Well, one thing is that these are all innovated by people who have been trained at CPDM or Center for Product Design and Manufacture. So let me give you a little bit of a background of this. So this is Indian Institute of Science or aerial view of its main building. Indian Institute of Science is probably the first example of public-private partnership in university formation. It was it started in 1909 as a result of the government of the Maharaja of Mysore giving the land, Jamshedji Tata giving the money, and the British government giving the permission. That's how it started. It is the highest ranked university in India by NIRF ranking and various other rankings. It's also 8th among small universities in the world. It has about 40 departments in science and engineering, including design, about 400 faculty members and about 4,000 students. The interesting thing about IISC is that most of its students are PhD students. So it's completely inverted. We have a very small undergrad program, a little bigger master's program, and a huge PhD program. And a very substantial proportion of engineering research papers also are published from IISC. We are one of the 3 strategic universities of Boeing Company outside the US. The other 2 are Cambridge University in the UK and Tsinghua University in China. Center for Product Design and Manufacturing is the design and manufacturing phase of IISC. It's among the top 3 design schools in India, according to QS rankings. It's also, if you count the number of high impact researchers, that is the top 2% of researchers in design practice and management, based on a Stanford University study this year, then our department is 7th worldwide and first in Asia in number of high impact researchers. So we are very strong in research, in design. So what do we want to do? We want to, of course, pursue excellence in all areas of design and manufacturing, so that we can help people develop systemically complex, technologically intensive, and socially impactful solution. And doing that by bringing together the functionality, the aesthetics, the usability, and the sustainability. Okay, so this is an important message for all of us, that when we are developing a solution, it is not just that it should work. It should work, it should be easy to use and easy to do many things within the human limitations for the kind of people that we are designing. It should be aesthetic, so people are able to like it. And it should also be sustainable, that it should use as little resources as possible. And we are primarily focusing on hardware-centric prototypes. So we have a Masters in Design program, M.Des. About 25 students are taken per year from all areas of engineering and architecture, and we train them in all of these technical, aesthetic, ergonomic aspects, so that they become holistic problem solvers. And they have to produce a working prototype in order to get their master's degree, and about a third to a half of these are patentable. We also have a PhD program in design and manufacturing, and this is actually, we started the first PhD program in design in India. We also have a master's in technology program in smart manufacturing. Once again, we take students from every area of engineering and train them to become somebody who can embrace traditional manufacturing with sensor systems and artificial intelligence to be able to develop hands-on machine systems and manufacturing technologies. We work with all big companies and small companies, and also lead the National Design Innovation Network by the Ministry of Human Resource Development and so on. And now smart manufacturing is also being taken into that. So what is it that we teach our students or train our students in? And this is where I bring in the innovation matrix. Okay, so you see here that as you saw the innovation cycle that I had presented earlier, it's not good enough to come up with just a product, right? It has to have the product, it must have the right production innovation, the right services and right business. So innovation can happen at any of these. You can have an existing product for which you may innovate its production process. You may have an existing product with an existing production process, or and innovate only its services. It is possible, or innovate the way in which the business is done. So all of these are possible. Therefore, you need to first of all have a mindset for innovation or thinking. Okay, and that is the only bit that I'm going to present to you today. But please understand, just design thinking alone is not enough. Okay, design thinking is only a mindset for innovation, which you need to have, but you need to have also a very detailed structured process. And the more complex the product, the more structured and detailed the process has to be for innovation. You also need to have the science and technology building blocks. And that includes not only the functional technologies that engineers may provide, also aesthetic technologies. Okay, how do we interact with the user interface, or usability technologies? Which ones? What are the kind of things that look good? What are the kind of things that give a certain message? For instance, if you're developing a very fast bike, I should be able to see the bike and be able to recognize that this is a very fast bike. I don't have to ride the bike in order to figure that out. So the messages that a product supplies must also be commensurate with the kind of functionality that it provides, right? And not least of all, you need to also have tools and with which methods and tools with which you can make all of these faster, cheaper, and easier to do. Development process can become simpler. All right, so it is design thinking, design process, design science and technologies, and design tools. All of them have to come together. So I have been using the word design for a long time, but I haven't introduced what I mean by design. So let me introduce this. And the definition is an adaptation from a very famous design researcher, scientist. His name is Herbert Simon, who had a Nobel Prize in economics, and he then started working in management and then started working in artificial intelligence and made phenomenal contributions to all of them. And then he started asking the question that what is it that is common across all these disciplines in which I've been working? And he essentially came to the conclusion that these are all disciplines that focus on producing artificial artifacts. Okay, artifacts means objects that are made by people, okay, or conceived by people. So they are not the sciences of the natural or natural sciences, but you need to have a science of the artificial. Okay, how are these artifacts created? What is the basis? What is the science behind it? So that's where this definition comes from. It is actually a very simple definition. You always start design with something that you don't like. Okay, for instance, village folks in India often have to walk a long distance in order to get to the nearest water source to do their daily chores. And this is something that many of us would think is undesired. Okay, why do they have to walk a long distance? They have to carry clothes and other things, and it becomes heavier. They also have to carry water back. There may be safety issues. The roads may be bad. Washing is effort and time consuming. Okay, and you can come up with a longer list. And depending on your intent or directions, you might want to make it more desired by saying, okay, why don't we bring the water source closer? Why don't you make the roads safer? Why don't you ensure that carrying becomes easy? Why don't you make sure that the roads are safer, and so on and so forth? Okay, so how do you make sure that the washing is less effort and time consuming, and so on? So here is an example that, and this is what you call goal. How do you go from undesired to desired situations? And to do that, what you do is you start planning. You say, okay, right, how do you change that? And if you're a designer, you will sketch and you make a plan. And you hope that if this plan is implemented and utilized as planned, that the undesired situation will magically change to the desired situation. So here is an example. Some of our students had created a rural washing machine that can be driven down to the water source, ridden down to the water source as a recliner by ladies, women, and it's completely natural and doesn't use any additional power, but only human power. Takes about half an hour to clean and gives the same cleaning quality as a commercial washing machine with the normal water, and then you can carry the clothes back in the same machine. Okay, so it's just now. Design is a plan for change. Okay, design is a plan for changing something that is not so desired to something that is more desired. And designing or design process is the way by which a design is developed. Please remember that when you're a designer, you are designing both the goal as to what the undesired situation is, what the desired situation should be, and the plan. So it is like, if I may use the comparison with a standard examination process. Normally in an examination, you give a question paper and you expect that the student will answer the questions, right? So they don't design the plan. They design only they don't design the goal. They only design the plan. Whereas in the case of designing, the students are supposed to design both the goal and the plan. So they should come up with a question paper and then they should come up with an answer to those questions. So both of them are important. And these designs, the plans can be for technical systems like a power plant, educational systems like a Montessori method, aesthetic systems like a logo, legal systems, and so on. The question is then, yes, so we can come up with goals and we can come up with plans, but then most of the startups still fail. So what's the big deal? What is it that we need to do in order to develop good designs? Good as in those that are more likely to be successful. And so this is where we need to look into the details of how designing is developed. Designs are developed, and we'll find, and I don't have time to go through examples, otherwise I would have talked about examples from architecture, examples from art, and examples from engineering to show you how everything that you see around yourself are trying to satisfy not one goal, but many goals. Okay, for example, a building typically will not only provide a shelter, a protection, physical shelter, so that people who are unwanted cannot walk in or out without being given access, but also that rains don't come inside, but light comes inside when required, and air comes inside, and so on. So there are always multiple goals. But there are actually many more goals than you can design for. So some goals are actually more important than others. Okay, giving a physical protection is more important than all the other ones. Not allowing the elements. Some of the elements is more important, and so on. Second is that whenever you have a design problem, goals, there are multiple ways of satisfying them. There are maybe 20 different ways of making a house, and some of the plans are better than others. So these are the two basic points about the way in which the nature of design. Okay, number one, that there are more than one goals, and some goals are more important. And second is there are multiple plans, and some plans are better. So the question is, which of how do you figure this out? How do you figure out, for example, what the goals are? How do you figure out which goals are more important? How do you figure out what are the possible alternative plans? How do you assess which of these possible alternative plans are better? And how do you then modify these plans so that they become better? So this is what design thinking really is. Okay, it is finding what the goals are. We'll start calling them requirements. Evaluate them to see which requirements are more important, and then try and satisfy them by generating solutions. So these are the plans, and then evaluate them to see which ones are better or worse or where they are not particularly good, and then modify both of them. Okay, modify requirements if necessary, modify solutions as necessary, and finally, when we are agreeable, that we select the requirement set and the solutions. And this goes on in a loop, because understanding requirements better helps you generate solutions better, and trying to, generating solutions also helps you see whether the requirements that you thought could be satisfied are indeed possible to be satisfied, and so on. So that goes in a loop, and this is what design thinking is. Now, in order to see the structure of those things, what we have done is we have made it simpler for you to remember. We call it IISC: identify, ideate, select, and consolidate. So identify is finding goals and requirements and evaluating them to find the right ones. Ideate is about generating solutions. Consolidate is about evaluating and modifying solutions and requirements, and select is about selecting requirements and solutions. So this is just a simple way of remembering design thinking, that it is IISC. Now, I talked about this as the way of thinking, right? But as I said, there has to be knowledge that has to come, the technology and science building blocks that have to come together, and in order to make the design happen. Okay, so it is not enough to have just the design thinking. Where are these knowledge coming from? They are coming from three parts. One is technology, one is business, and the other is society. Okay, now this is a very simple diagram to clarify what is it that an innovation is trying to do. An innovation is an offering that a business is trying to make by combining technologies that exist or creating new technologies. And based on that, they are making a value proposition to the society. Okay, they are saying, okay, this would be of value to you. And if society is happy with that, then the society gives them profit. So there is a transaction. Now this is true for any kinds of business. Okay, now that profit may be for individual consumption, that profit may be for societal consumption. Okay, so you can have social innovation, or you can have private innovation, or you can have innovation from a government, but doesn't matter. All of them must have this basic thing, that the business proposes value, and if the society is happy, it gives profit. Okay, and for this transaction to work, both business and society must be happy. The reason why most startups fail is because the business is not able to provide a value for which the society is ready to give profit. So what is value? Value is performance by price. So what the innovation provides is performance, and what it asks, okay, in return is what is called price. Just hold it. What is profit? Is price minus cost. Cost is the resources that are used to produce the innovation. Price is the resources that are asked from the society in exchange for innovation. Okay, so if I put that in this one into the other, I can get this kind of relationship. Profit is performance by value minus cost. Remember, cost is broadly interpreted, including the cost to the environment. And then for the win-win to happen, of course, value has to be high enough and profit has to be high enough. And as a designer, you have two elements in your hand. One is performance and the other is cost, because price is external to you as a designer, and therefore it is decided more by the market rather than you. So the two parameters that you can play with is performance, things that you want more, and cost is resources that you will then spend. So here are some examples of what design does. Design takes this knowledge from the society, the business, and the technology, and brings them together in order to go through the design process. Now, to do that, also this knowledge also comes in two different forms. One is called domain knowledge and the other is called process knowledge. So I'll show you what it means. This is an example of domain knowledge. Okay, this is a micro accelerometer. Okay, so for those who do not know what an accelerometer is, meter means measurement, accelerometer means acceleration. Okay, acceleration is the rate of change of velocity, right? So if something goes faster and faster and faster, we say it's accelerating, right? So this is an acceleration measurement instrument which is used in airbags, for example. Okay, when cars meet with an accident and they have to suddenly stop, its acceleration or its velocity change is sudden, and that sudden change is sensed by this measuring instrument, and then it operates a switch to open an airbag which inflates and provides a barrier between the person who is driving, for instance, and the hard objects against which you would get hit otherwise, so that he has a soft cushion in between, which allows him to probably survive. So this is something that many years ago was designed. This is one of the examples of such, was designed in 1995 in Cambridge University. And what you see, for those who have a technical background will probably understand, the middle bit is a small mass, okay, and the side two lips that you see here and here, these are like a overhang cantilever, like a beam, and so when acceleration happens, this thing goes up and down like that because of the stiffness of these two beams here, and there is a small protrusion here at the front. Okay, it's actually very close to an electrode on the other side. So when these two come very close to each other, this backstraight and substrate and this lip, some electrons will jump from one side to the other, and that's called tunneling. So when that happens, that becomes a measurement of how much acceleration is there. The more electrons jump, the more close they are, the more the acceleration. So in order to understand this principle, you need to know what is called tunneling. Okay, and also these are very small objects and about 1 millimeter by 1 millimeter. So you need to have the way of means of manufacturing them. Okay, at that kind of size, which is called microsystems manufacturing. So these are examples of domain knowledge, right? If you don't know tunneling, if you don't know microsystems manufacturing, you are never going to be able to design a micro accelerometer using these principles. So that's the importance of the domain knowledge in addition to the design knowledge, design process knowledge, for you to develop something, design something. Now, here's an example of process knowledge, right? This is an example of an acid bath. Okay, so this is the black thing. Is an acid bath just in a cartoon. The blue bit is the acid inside the bath, and the yellow bit is a specimen that you want to test its corrosivity. Okay, how corrosive the acid is for this object. Okay, how corrosive this acid is for this object, and how do they do that? They put this object inside this acid bath for a certain period of time and see how much change in dimensions has happened to the object. Okay, that's a measure of corrosivity of the acid on that specimen. Now, one problem with this design, its design is that the acid corrodes not only the specimens but also the lining of the bath, and which leads to expensive change in the acid lining. Okay, which is not a good solution, because we say that value is performance by price. So in order to perform that, you have to pay a lot of price, and that's therefore is not a great solution. However, you can think of this solution also, where you make a little hole on top of the specimen, and then you put a drop of acid there, you leave it for a while and take it out. And now you are using the specimen as an acid bath, right? And that solution is much cheaper because you just need to modify the shape of the specimen, and you need far less amount of acid also, and you don't leave this in expensive lining. Now you see, in order to go from the previous solution to the current solution, you did not require any further domain knowledge. Okay, so even with domain knowledge, you could come up with this solution. And the question is, how did you come up with it? And that is to do with another kind of knowledge, and that's called process knowledge, which is also important in design. And I'll give you some examples of that. Okay, so let's look at it. So examples of domain and process knowledge in society. You need to understand the value. Where do you understand the value? What is it that people value? So you have to interact with the society and find it. So here's an example. This is Damien Mycroft. He was a senior design manager at Nokia, and he was walking through the streets of Mumbai one day, and he came across a boy who was trying to do welding, and he was not able to do well. And he was also trying to listen to music. Now, and of course, he was struggling because welding creates a lot of sound, and music was not easily heard. And this is not the most exciting job, so he needed entertainment. So then Damien Mycroft said, why can't we make a louder mobile phone? And that led to the development of slim speakers in Nokia X6, which was very popular a decade ago. So you must understand the needs of the user, and in order to understand that, you may require domain knowledge of the user. So you can do studies of the user, saying, okay, this is the kind of aspirations of users of this kind. This is the way they live their life and so on. Or you can take process knowledge. You can ask them what kind of things they want. Immersion is one such example of how that process can be carried out. Focus group study is another one. Second part is profit. Okay, so business, similarly, there are examples of both process and product knowledge or domain knowledge in. So here's another example. This is a so you see the person who is sitting there. Okay, this kind of people have a disorder called muscular dystrophy. So people who have muscular dystrophy, they have a problem of moving their arms or body parts up and down, because dystrophy comes from dystrophin, which is a protein that communicates between signals that come from the brain and transmits that to the muscle. So if dystrophin is less, then you don't have the messengers that are telling the muscle that you need to work now. And as a result, the muscles don't work or don't respond. And people become wheelchair bound, and typically men will die by the age of 20, and women will survive, but they will survive with a very low quality of living. So in order to help them do their daily work, I was part of the team where we developed a mobile arm support. So you see the arm support at the back of the wheelchair, the metallic rod that you see, that's a nut that that's a screw that rotates inside when a motor is operated at the bottom. And this white bit that you see here, this goes up and down, okay, like a nut. When you rotate a screw, a nut moves up and down, right? And this sling, the hand is held by a sling with enough degree of freedom with which the arm can be moved around in a horizontal plane by the person. And if the arm has to be moved up, then they can use the switches in order to operate the motor, in order to operate the screw, in order to move the nut up and down, and therefore hand up and down. That's how it works. So it's a very simple design. But the dystrophy group, they felt that this is very good and they want to take it out to the market, but they were not able to, because it doesn't make profit sense. Okay, if a company is going to make this product, they would expect a decent amount of profit. However, this product is for customers who are wheelchair bound. They don't exactly work, so they are dependent on either their parents or other relatives or the government for survival. So they cannot pay high price. Now this product, if it goes wrong, it's a bodily product, medical product. And if anything goes wrong, they can sue the company. The company has to pay a hefty fine for that, right? And so what the company has to do, it has to create a large insurance. Now, when it takes a large insurance so that it doesn't go bust, then where does it take the insurance money from? Again, from the customers, right? Which means that the cost of the product goes up, which means that people are not able to pay. So there is no profit or very little profit, which is something that companies, of course, would not be able to survive with. So for many years, this did not see the light of the day until the government said we are going to provide a subsidy with which the difference in the two can be met. So once again, you can see that you need to have domain knowledge of costs of materials, manufacturing, and so on. But you also need to have the process knowledge of modeling costs. Okay, how do you cost the life cycle of a product? How do you cost the concept? When you're developing an idea, how do you say how much is it going to cost? How do you cost the environment? Okay, how is this product going to go out to the society and the environment of the society and make hazards there? So again, you need process knowledge. Finally, similar things can be said about the process knowledge and domain knowledge of technology. For instance, this is Rolls-Royce Trent 700 engine. This engine is one of the most successful engines that Rolls-Royce has developed for aircraft. And there is, of course, it has problems. For example, you see this nose cone here. When the aircraft is flying at 25,000 feet at 1,000 kilometers per hour at minus 50 degrees Celsius, 50 degrees Celsius. Okay, and this little cone has a nice place where ice starts forming. This ice then
cross check करो.
Can you please put it on mute?
Hello.
आप लोग यहीं बैठ जाओ. इसको अभी खत्म करके भेजते हैं.
Hello.
उनका वो आ जाएंगे, वो ज्वाइन कर लेंगे.
Hello, can you please put this on mic?
किसी की गलती नहीं है. वो लोग 10 बार 10 चीज चेंज करा रहे हैं. कॉपीज हो
Just
जाती
put
है.
everybody on mute, please.
हम लोगों को कोई slide, we can't see slides. How this FDP is going on without we can see the slides.
Why didn't anybody say that to me? It's a waste of time for everyone.
No, we are seeing the sound slides, sir.
Okay, so are
able
people able to see? So maybe that is a problem with that lady.
No, it's visible, sir.
It's visible.
Okay, I'm sharing it again and see if that makes any difference. Okay, okay, are you able to see the slides?
It's visible.
It's
Yes,
visible.
sir.
Okay, okay.
Technology
Okay, fine. So
feasibility.
can you
Yes,
put
sir,
everybody on mute again, please?
Yes, sir, doing that. And request all of you to please mute your mic. Suddenly if you start, then it disturbs the speakers or everybody. Yes, sir.
Okay, shall I start?
Yes, please, sir.
Okay. All right, I'm making full screen. So what I was saying was that this Rolls-Royce Trent 700 engine, it had a problem. Okay, and that is the problem of formation of ice. Ice starts forming in this nose cone, and ice is like a stone, right? It flies at 1,000 kilometers an hour, and it will then go and hit these, and it's highly breakable. So it goes and hits the turbine blades and basically damages them. So this has been a problem that engineers have been looking at, and they came up with first solution, which is to heating the cone. Now this is a very expensive solution because the outside temperature is minus 50 degrees. So remember, value is price by performance by price. So price will go up. So that's not a good solution. Then they came up with the idea that we can make this in two parts, the front part. Okay, and the front part is more like a cone, and we'll put a small motor there which will keep on wiggling. Okay, and if it keeps on wiggling, then the snow will form, but ice will not get time to form. Okay, so you can see that the cost has come down. As a result, the performance by price has gone up, which means value has gone up. Finally, they came up with the idea that we can make this portion with a slightly more flexible material, and there is enough vibration when the aircraft is flying. Therefore, you do not require a motor or anything. It can simply take the vibration from around, starts slightly vibrating, and as a result, it doesn't require any additional cost. from running cost. Now, again, you can see that you need to have domain knowledge of the various technologies. For example, the principle of heat transfer, principle of materials and so on, motors. You also need to have process knowledge of how to create ideas. How do you come up with the idea? Why? How can we not come up with all three ideas at the same time so that you don't have to do it in a serial manner? Okay. And again, there are various methods like brainstorming, trees and so on, or biomimicry that you can use for that. So just to summarize, you need to, of course, have domain knowledge. You need to have creativity or process knowledge. You need to have the motivation. You need to have communication. You need to have interpersonal skills, and most importantly, your ability to learn. Okay, because knowledge keeps changing, and you need to be able to adapt to that. Okay, so I'll skip the rest of the slides because I don't think it's we have come to the close to the meeting. I think it's time. So I'll skip the list of the slides, but I think the important messages are already given, which is that design design is important for innovation and growth, and you need to be systematically trained in order to design well. It's not good enough to just innovate, but innovate with the knowledge of design. Thank you.
Yes, thank you. Thank you so much. So shall we take a few questions if somebody is having?
Okay.
So if you have time, sir. So one or two questions if.
Okay.
Yes. Participants, if you have any quick question on this, so this is all sir has explained. So starting from their own, the journey. So if you have any question, then please quickly ask one or two questions.
Good morning, sir.
Good morning.
Sir, I am Janakiram from Andhra Pradesh.
Yeah.
Okay.
With all your experience, help me to understand where can be the potential place where design thinking can fails.
Where design thinking fails.
Where design thinking can fails. Potential places where design thinking can fails.
I've not seen it fail at all, ever. But please remember that design thinking alone is not enough. I tried to impress upon you. You need to have the domain knowledge as well.
Yeah.
Okay. So design thinking is not magic. It's not going to solve the problem for you. Design thinking is important, but so is domain knowledge. So domain knowledge has to be integrated using design thinking. Next question.
Thank you, sir.
Sure.
Sir, I have one second question.
Yes.
I am an MBA faculty.
Okay.
If I want to do PhD in IISC in design thinking, would I need to have a domain knowledge like all these technical knowledge, things like that? In what area, what stream of PhD in design thinking I should choose?
What is your undergrad? What is your undergrad in?
BCom.
Yeah, I think the IISc will not be able to do that because you need to have domain knowledge, because most of the examples that we'll be using would require domain knowledge of some area of engineering or other. But you should be able to do a PhD in I suppose in a management institute like IIM Bangalore.
Okay. Good morning, sir.
Because we don't work on non-technical areas. Yeah, go ahead, please.
Good morning, sir. I am Vijay Lakshmi from Tamil Nadu.
Okay, good morning.
Sir, in IISc Bangalore, with which institute do you have a tie-up for commercializing your product? For example, if you have made a prototype, have you commercialized that prototype with any of the industries in India? Or do you have any collaboration with foreign universities or companies or universities to commercialize it?
Okay, thank you for your question. So there are two routes for commercialization. Okay, one route for commercialization is that we have an intellectual property office at IISc, and the intellectual property office works with companies to say, okay, we have these are intellectual properties. So we take patents, for example, or design registrations, and this intellectual property office will then have a licensing agreement saying that fine, you can use that and you need to pay us money for that. So that's one model of commercializing. It's called technology transfer model. The other model of commercializing is we have incubators in which the people who have innovated the solution, they can create a company, create a startup, and that is nurtured and mentored. And then the expectation is that then they go out and become a company on their own, and that's another way of commercialization. So we apply both the routes. Okay, so we can transfer the technology or we can create our own companies.
Thank you, sir.
Thank you.
Good morning, sir. I'm Indrila from Mumbai. Sir, I wanted to ask you, you spoke about environmental cost. So,
Yeah.
so much of product innovations happening all the time, packaging innovations. So how is this environmental, are companies actually calculating the environmental cost and adding to it? How do you factor in that element? Because that's creating so much of damage. I mean, you can create a fantastic product, fantastic packaging, but at the end of the day, I mean, every day when I see, I mean, there are so many startup companies and food companies, they are sending us goods, we are buying things online, and the packaging which comes is just lying waste. So how does one factor in the environmental impact that they are creating?
Right. So, from the point of view of whether they are doing or not, that will be very much driven by two aspects. One is the customer refusing to take products because of that, and two, whether the government is producing, so society at large, which is what translates to a government, right? Government is producing laws with which things are banned or prevented. So what is happening is right now, neither of these are very strong. Even if I think somebody has again turned on the...
Then opposite road undi, then that college దగ్గర నేను వస్తున్నా. ఆ రోడ్
this is a very simple practice. Can you please put your mics on mute?
Hello.
I mean, why does it? I don't understand this.
Sir, 1 minute. Let me just mute all again. Yes, sir, I have muted all. Please unmute yourself and please explain, because there was some background noise, sir.
So what I was saying was that there were two aspects. Okay, one is that the society at large decides, okay, we are not going to have this garbage, and therefore there is a law against garbage. So that's one way to do that. Second way to do that is that you as a customer, when you buy something from, let's say, okay, whoever the service provider is, and say, okay, if you provide this much of packaging, I'm not going to buy it. Okay, these are the only two ways in which you can prevent this from happening. And right now, neither of these is very strong. We keep complaining, but we still keep buying. We don't refuse. And the government laws are not very strong because the society at large has not decided against it. So designer therefore doesn't take this into account in general. Okay, having said that, there are some forward-looking companies that use this as a strategy. Panasonic, for example, the Matsushita, they took up themselves in 1990s that they are going to make a zero waste kind of product, and they came up with strategies and so on. So there are technologies that are available. For example, life cycle assessment. With that, you can actually figure out what is the likely impact of a product on the environment, and you can take that into account in designing and redesigning the product. However, the environmental movement is relatively weak right now.
Yes, sir. So there's no design thinking happening around that area, unfortunately, because every day
there are enough tools that are available. You just need to do your literature review and you will find. But their implementation is weak because
I meant
no strong incentive.
Unfortunately,
so the knowledge exists. However, its implementation is not happening because of the incentives not existing.
Yes, sir. Yeah, thank you, sir.
Next question. Sure.
Good morning, sir.
Good morning.
This is Tushar from Nagpur. You talked about cost and all those things. So would not that be a at initial design thinking level, that be a constraint or a hurdle in developing or in coming up with a good, what we say, options or means that we can design. If we initially
If
thought
there are
about
no
cost and
constraints,
all.
there is nothing to design. It's because of constraints that a design has to be developed. Otherwise, anybody can design anything, right?
Right.
Cost is very important to take into account. Many times it has been seen that when you have constraint, your creativity increases.
Okay.
For example, when we don't have so much to waste, that we become more careful in how to preserve things. When you have more money, we tend to waste a lot of stuff. So I think cost is the sensitivity of cost is very important in designing, because ultimately anything you offer, it has to be offered at a certain resource. Therefore, that is also part of your innovation process. How do you offer something within the resources within which it has to be done? It is for some people and they have a certain ability to pay. There is a society that has a certain ability to pay. It has to be taken into account.
Okay. Thank you, sir. Thank you.
Okay. Okay, I think there is no other question.
Yes, sir.
So I think we should close.
Yes, sir. So I just want to thank you for
Sure.
explaining the basic concepts and few good examples that might not have seen. Anybody has seen that Galaxy example and the Rolls-Royce engine example, which is unique, and we all can see the tremendous work done by IISC under your leadership, especially for the CPDM, the department center, and definitely will be in touch with you. So for next, whenever we plan this kind of the design perspectives or design thinking perspective, so we'll invite you. And similarly, we'll all have this kind of your the basics for inputs, valuable inputs for this design thinking. So on behalf of Brajesh,
So maybe I just want to say one word before that, Tushar. I think this, because these are teachers that I'm speaking to. I want to just say one word of caution. See, normally what happens is when we teach a regular course, like mathematics or physics or chemistry, typically the knowledge is out there in the book. Knowledge is out there in the book, and we can read that, we understand that knowledge, and then we transmit that knowledge. And the student are expected to understand that knowledge. When we are teaching design, okay, or we are in a design thinking course, most of the time the teachers actually don't know. Okay, we do not know, and many times the students are capable of doing far more than we teachers are. We need to understand this particular difference in design thinking. We can teach them design thinking, but what they produce using design thinking may be far better than we as individuals would have been able to produce. So this idea of teacher knows more than the student fails in design thinking course. So this is something that I want you to be aware of, and have the humility to allow the student, okay, to come up with answers that we are ourselves not capable of coming up with. Okay, it is not a typical chemistry physics type of course.
Yes.
So it is important that we are more like enablers. We are more like facilitators, and therefore their creativity must grow. That is the part. Okay, it should not get stifled by our inability, saying, "Oh, I couldn't come up with that idea, therefore it can't be very good." So we need to allow that freedom for the students for these kind of courses. Yes. That's my only other submission to all of you, because we are in the same job as teachers, and I have seen over and over again that my students are far better than me in coming up with ideas. Yes. I must allow that to happen and do not stifle them. Encourage them to be better than us.
Yes.
Okay.
So you are rightly said, and that's why we might be engaged in fully as a silent director, or we can say as an inventor in few companies. But we have mentored more than, say, for example, under your leadership, almost 1,000 of innovators have grown up. So that is the sign. Everybody, I request all of you to have that humility and have that point of view and perspective to make our student far better than us. So this is the takeaway from this this session, and we definitely look into that, sir, and we'll try our level best so that we can build our nation very stronger, strengthy. So thank you so much on behalf of Graduate School of Management Studies and Gujarat Technological University for sparing your valuable time on this the very important topic. So thank you so much, sir.
Thank you. Thank you.
Yes, so participants will have a 5 minute break, and then we'll start our next session probably by 10:40, around 10:35. Once we invite our next speaker.
Please do not leave this meeting. This
Yes.
meeting will continue, and we will invite our next speaker in this meeting itself.
Yes, he has already joined. Our next
Okay.
speaker has already joined.
એ કરમજીતનું આઈડી શું છે? ક્યાં નામે જોઈન થયો છે? સ્પેલિંગ શું છે? હાય કે કર્મ KRM મને કેમ નથી મળતું? કરણ ભટ્ટ મને મળે છે. તમને દેખાય છે? Once again, good morning to all. We are ready with the second session of the second day of 5 days National FDP sponsored by ATAL and organized by our GSMS. Our expert is available now with us, and I request Mr. Tushar Panchal to brief about the expert. He is a very renowned person in the field of design thinking or design specifically. I request Mr. Tushar Panchal to please give the introduction of the speaker.
Yes, thank you, Kaushal Bhai. So, dear participants, so today we have Karamjit Singh Bihola, who has started or who has initiated the design engineering concept or design engineering into the academia at this university itself. So he has worked with Gujarat Technological University, and he has almost we can say conceptualize all the design engineering, the phenomena, or you can say all the terminologies which this academia never knows. So in engineering, it was initiated with design engineering subjects. So he has done product design USA, that MS from USA, especially into product design. So before that, he has done BE Mechanical, and now after serving the Gujarat Technological University, recently he has started his own the startup, we can say, especially on design thinking, and that is so-called InnoDesk. So he is going to brief on that also, how this InnoDesk is working, and dream for Bihola is design thinker at mindset and entrepreneur at heart, having master degree in specially this product design, that is mechanical engineer with specialization in product design from Stevens Institute of Technology, New Jersey. Also working as an evangelist to develop, implement, and spread the awareness about the concept of this design thinking, innovation, and entrepreneurship in especially higher education.